All right, hello everyone. Will McBurney here. So today we're going to be talking usability, and when we're talking about usability, the first thing to note is that uh, a system's interface is like a joke. If you have to explain it, it's not very good, and that's the idea that we're going to get to today. And when we talk about usability, we're talking oftentimes about design because we're talking about designing a user interface. But that is actually very different from the design we've talked about so far. So far, when we've been talking about modularity, about how to decompose the system, we're very much talking about internal software quality, making sure the system is changeable, testable, stable, analyzable, right? Easy to understand. But from there, there's also external quality considered, putting this product in front of the customer. And part of design is thinking about what the user interface is going to look like. And we want to make sure that the system has a good user interface. And an interface can be pretty unhelpful if it's bad. For example, here we have a touchscreen, forward, backward, left, right, top to bottom. I bet you can immediately think of improvements to this, such as moving the left button to the left side, moving the right button to the right side, things like that. If you just need to display information, say information of doctors, wouldn't it be nice if they were sorted in some meaningful order? Wouldn't it be nice if these were structured the same, structured as a table, so all the distances line up? We then wouldn't even need to have distance on every single line. I have seen an app with these buttons on the bottom: submit, quit, exit, and stop. I never figured out what the difference in quit and exit was. Stop was used to leave the form that you were filling out without submitting, but to return to the previous page. So could arguably be a back button. I still don't know the difference between quit and exit when I use that program. So I'm going to give a very, 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 very brief history of computer user interfaces. We're then going to talk about the Therac 25 test case and how a failure in usability actually did, in fact, lead to human death. We're going to then look a little bit into the design of everyday things and then translate that into the design of software. So first, the earliest computers were very much not usable. You had to be an expert to use them. You would have physical wires connected between different systems, or you'd have punch cards. From there, eventually you could start typing to the computer and interacting with a bunch of buttons and switches, as you can see there, to make the computer do different things. The first mouse emerged, by the way, in about 1968. That showed up so fairly early, and of course they're ubiquitous now. Then you start to see the home computer revolution, it was important then to have graphics user interfaces in order to make the computer more popular to a wider audience. Of course, now it's fairly ubiquitous, but there was a time not that long ago, all things considered, where most people didn't have internet in their home. Of course, now we have these modern interfaces, these touchpad interfaces. I mean, I have still a keyboard and mouse here. I'm a geezer in that respect. And then, of course, the thing that I think every usability designer hates is the movie Minority Report. It was like gesture interaction, and people have made it, but the thing is that it turns out that when they've actually tried to replicate this, and the technology is there to actually do that now, not the holographic part of it, but the moving things around, it turns out it hasn't worked very well. The next step is kind of like computer vision, having a computer be able to look at something and interpret what it is. That could be very useful for interfaces and interpreting gestures and things like that. But more importantly, why is usability important? Let's talk a little bit about Therac 25. It was a radiation therapy machine. It was involved in 6 accidents. Why did it occur? Well, during treatment, the machine stopped and reported no dose, and this was a common occurrence. And so the technician pressed P to re-deliver the dose. This happened 4 more times, where it would stop and say no dose, after the patient had received the dose, but because there was a hardware failure in place. Hardware software interaction failure in place. So the patient received 5 times prescribed dose of radiation therapy, and they died 4 months later. Tyler, Texas, 1968. Operator who was used to using the machine, press X for E and for X-ray instead of electron, and they meant to press E for electron. So they went back to edit it. They hit enter. They hit E, and then pressed B for beam, so the electron beam. The machine shut down and reported malfunction 54 and treatment pause. And this bug occurred because he hit X-ray, and then while the hardware was switching the X-ray system into place, he then hit back and hit E, or she went back and hit E. And so it, instead of turning, though, because it was still locking into place the X-ray in that duration, it ended up just ignoring the user when they wanted the electron dose. And so they eventually got the electron beam in place, but when they did, this malfunction 54 showed up, which wasn't present in the user manual. So as a result, the operator who had requested 202 units from the machine was told only 6 units had been delivered, when in fact 202 had been delivered. And this happened twice, so the patient got significantly more radiation dose than needed. Patient died 5 months later. Again, another incident, similar case, malfunction 54. No one knew what malfunction 54 was. The system did not say malfunction 54 : blah, 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 blah. It didn't say that. It just said malfunction 54. And no one knew what that was. And they were able to restart the system, and they did it. And then another patient died 3 weeks later. So, poor feedback was critical there. Incorrect feedback, misleading feedback led to people dying. So, how do we avoid that? Well, we make software usable, but how do we make software usable? Well, the first thing we have to ask, how is anything usable? And the famous book on this is The Design of Everyday Things by Don Norman. You can see the teapot there. If you ever get a chance, buy it. It's a great book. I love the teapot just because it would be very difficult to use. And the common example that comes out of this book is Norman doors. So here we have a bunch of doors, like this horizontal bar for pull, these little paddles for pull, this bar, do you pull or push? It's not clear. If you have to write pull on your door handle, chances are it's not a particularly good door if you have to tell someone how to use it. And in fact, I mean, it goes against my instinct. I would assume that I would push here and push here, right? This door in particular hurts my head. I don't know if I'm supposed to push on the left or the right side. If I look up, I'll see, okay, the hinge is there, I go on the left side. But I could just as easily see someone try to push on the right side and it not work. So, and this is a classic little Far Side comic. But with that, Norman doors are bad because they use visual clues, and again, I'm going to pull that up. They use visual clues to indicate what you should do. Like, this horizontal bar is just naturally for push, right? You do a pulling motion by pulling this way, and it's more comfortable to pull with your hand turned sideways, so that's why the bar is vertical. And with push, you can put your weight into it pretty easily if it's kind of low and mid-level, and you just kind of push down on it. This bar indicates push. It is actually pull. So that is when a visual cue, like a horizontal bar, indicates push, or this little paddle indicates push because doesn't look like there's a lot of space for a hand. This vertical bar seems to indicate pull, but you would assume one side of this door is push, not pull. It's not clear which. You know, there's visual cues at play here that are not helpful. So let's look at an example of a system that a user interacts with. And let's talk about why this system is bad. This is a refrigerator example. These are instructions on a refrigerator, and you know, you can see things like normal settings, C and 5, warmer fresh food, C and 4 to 1, coldest fresh food, B and 8 to 9. And I want you to pause this video after I'm done explaining it. We're going to have a freezer section and a fresh food section. And I want to tell you right now, your freezer is too cold, but your refrigerator is too fine. How do you adjust these settings in order to get the freezer right? Should note, it takes 24 hours to stabilize, so if you get it wrong and your refrigerator warms up too much, you could have food that spoils. So, take a minute, pause the video, and try to predict what settings you would need to set if currently you're at C5, but your freezer is too cold, but your refrigerator is fine. What should you do? I'm assuming you've paused the video. Here's the problem with this. This interface creates what we would call a conceptual model, right? I have a dial for freezer, and I have a dial for fresh food or refrigerator. So what my brain immediately thinks is this dial, freezer, controls the temperature compartment for the freezer, and this fresh food controls the temperature for the fresh food. But that's actually not correct, right? That mental model, which would be illustrated over here, this is not correct. The correct conceptual model is I have a cooling unit, and the control A, which is the freezer control, changes the temperature on the cooling unit. And control B controls a valve that determines how much cold air to direct to each side of the system. How much cold air goes to the freezer, how much goes to the fresh food. This model A on the left is wrong. Once you understand this model B, you might have a better chance of correctly making the adjustments that you would want to do. For instance, if your freezer's too cold, now that I know the model, well, if it's too cold, I need to turn down the temperature. So maybe, or I turn up the temperature a bit. So I'm going to turn, say, freezer up to D. But then fresh food, because I have more cold, or I have less cold air, I need to send less cold air to fresh food. And so maybe fresh food is going to go to, say, 4 or 3. And I can try that. Because I have the correct conceptual model, not saying it's easy, but I can at least make an informed decision. The conceptual model the interface implies is wrong. And that's the idea of an interface. You approach an interface, you immediately start forming conceptual models about how to use that interface. And when they are wrong, it can be jarring, and it can also cause you to make the wrong decisions. So what we want is we want to design our interfaces so that they are the conceptual model that they are most likely to communicate is a valid and helpful conceptual model. Here we go. 5 E's of design: effective, efficient, engaging, easy to learn, and error tolerant. Effective, it correctly accomplishes the task. Efficient, the user can accomplish the task through the interface with the minimum effort possible. Engaging, the user wants to learn the interface. Easy to learn, the system reveals its features in such a way that the user can quickly understand, as well as learn advanced usage over time. And we'll talk about some examples of that in a second. And then error tolerant. This is a big one. Able to recover from user errors. If I do the wrong thing, I want to fix it. Outlook actually has a useful tool for this. If I send an email and I immediately think, wait, I need to edit that, if I close Outlook, it actually holds the email for 30 seconds, and so I can prevent it from being sent. You know, that's better than, you know, you can't recover it at all. Why did I not list intuitive? Well, besides the fact that it doesn't start with E. Intuitive means in sync with someone's intuition. But not everyone's intuition is the same. Example, when I was teaching Intro to Java at Penn, which was our intro programming class, I did not use Eclipse. I used a tool called Dr. Java. Dr. Java does not have autocomplete. It does not have dynamic compiling, so there's no red underlines of shame to tell you you need to fix something. There is no immediate error feedback. You have to start to compile the program, and then you get the compile errors. You have to run the program, and then you'll get the run errors. There's no warning system at all. Eclipse and IntelliJ have all of those, so why don't I use that when I'm teaching Intro Java? Well, Eclipse and IntelliJ also, in order to just simply run a program, require a steeper learning curve. And when I'm teaching people who have never programmed before, as I did in this class, I'm going to use a different interface for them. What is intuitive for those students who have not programmed before is going to be very different than what is intuitive for a bunch of experienced programmers. So that's important distinction to make. So how do we design for usability? Well, you need to consider two things. The first is the persona, and the second is the scenario. Persona. Who are the users? What is their pre-existing knowledge? What is their motivation? Scenario. What are you trying... What do you think a user is likely to want to try to do? What else are they dealing with? And what are their expectations? A perfect example of where persona was not considered and scenario was not considered is, if you remember in 2020, the Democratic primary in Iowa took a very long time to finalize its results. There were a lot of areas that had significant trouble counting. Why is this? Well, a lot of the voting software had been redone, and one of the things that you should take into account is, one, many poll workers, simply for tons of reasons, the average poll worker is significantly older than the average American. The subset of people who work the polls tend to be older, which means they tend to not have grown up with even cell phones, let alone smartphones, which means they're not necessarily very comfortable using smartphone apps. And yet, the voting tally system for the caucuses was through a mobile app. Further, Iowa's very rural, which means that a lot of the cell phone networks there, I mean, you're not seeing any 5G. Well, not really. A lot of the areas have very spotty and slow connections. So the fact that people may not be comfortable using smartphones who had to use it, that's persona. The fact that the cell phone towers were not sufficient for communicating the information, that's scenario. That's the difference. And you need to consider both. And so, let's talk about evaluating usability. How can we evaluate it? Well, there's a few different ways to do it. One is through the use of heuristics. That is general guidelines or widely accepted best practices. We can do usability studies, which, you know, you could do this as a form of beta testing, have a user work with the system under normal circumstances and evaluate them. And then there's actually, like, statistical measures that you can use as well. And one of the most popular set of heuristics is Nielsen's usability heuristics. For example, match system between system and real world. For example, here we have this idea of a file folder, right? And the file folder looks like a folder full of files. And if you go to iBooks, you know, your books look like they're on a bookshelf, and you pull the book out and it visualizes your books as though like they were on a shelf. That's a useful real world connection, because it immediately communicates a lot of structure of how the system can be used. Again, I emphasize how the system is used is not the same as how it actually is. For example, you may think of a file folder like this, where you have some root directory and that contains folders and files, which contain folders and files. This is a useful metaphor, and it's a very good communication tool. It is not actually how files are stored on a disk, right? How files are stored on a disk is there's this table that keeps track of basically which sections of information are assigned to which file, and it can be very chaotic and unpredictable. But this is a useful metaphor. And in fact, we've made this so commonplace that many people are surprised to learn that files are not actually stored like this. Consistency and standards. Here's a bunch of different versions of Microsoft Office. This was 2012 because that's the version I have. In 2012, notice that you had, home insert page layout, home insert page layout, home insert design for PowerPoint, since it's not page layout, but design is a lot like page layout. Look, paste, same rough place. We want consistency. Save, undo, redo, print. We want that consistency. This image is not showing up well, so I'll expand it. Notice that yes is on the left side. Yes is on the left side of both of these. And typically it's yes, no, cancel if you have 3 options. Anytime yes is on the right, it actually throws me off because in most Microsoft applications, it stays on the left, making it predictable. Meaning if I'm not giving the system my full attention, I can still use it because I can rely on my muscle memory having used the system. Help and documentation. Have it available somewhere. Go back to Therac 25. There was no malfunction 54 in the user documentation. You need good user documentation for your system, especially for more advanced usage. User control and freedom. There's a lot of different ways to do undo, redo. I can just hit these undo, redo buttons, or I can do Control Z and Control Y because that's faster for me. I can right-click, copy, paste, or I can Control C, Control V, which I'm more experienced, so I've started to use that for the sake of saving time. Give the users much more control by saying, okay, you're going to copy desert landscape. Do you want to copy, replace? Do you want to not copy? Do you want to copy but keep both files? This makes it very clear. This is a great window. This makes it very clear. What options do I have? It lets me choose which one I want to do. It doesn't pick for me. And it makes it clear to me what the consequences of my choice are going to be. That's great user control and freedom. I have the option to do what I want, but I'm also clearly informed what my actions entail. Visibility and system status. If it's going to copy a long time, let me know how long it's going to take. When starting up a Linux machine, you get all these OKs, which can take a while. Status. This file is not compiling correctly. I can visually see that. Flexibility and efficiency of use. This gets also back to the Control Z. I can use keyboard shortcuts, or I can use left click, right click. Error prevention. If I'm about to do something that I cannot undo, alert me. Like this is why you have to confirm when you want to delete a file, because it can't be undone in some circumstances. So you have to make sure. If I save and overwrite, that previous version of the file is gone. I can't undo it. So make sure that I know when I am about to do something I can't undo. Recognition rather than recall. Don't expect me to know which font I want. It shows me a sample of the font. That's great. Safari browser. You can often start with a window like this, and I can choose which website I want to go to, not by remembering CNN.com, but I can say, oh look, CNN.com, that's where I want to go. I want to look at some news. You try to design your system so it relies not on the user remembering how to use it, but that they're recognizing how which options they want or how to use it. Help the user recognize and diagnose errors. IDEs, Eclipse is great for this. This is bad, right? I don't know what this is. An internal error occurred. The internal error code is displayed above. I have no clue how to even Google that. This is good, right? If I were to enter 81 for the birth year, which is actually that is a bit before I was born, but it would clarify. Oh, please enter a birth year 4 digits. This is pretty clear. It's telling me what the error is and how to fix it. Aesthetic minimalist design. This is very popular, although I should note that Windows 10 certainly has fallen off a bit, but nonetheless, minimalist design. Don't clutter the screen with things that are going to distract the user if they're not likely to use them. So those are just some heuristics that are popular. Now let's talk about usability studies. It is not just surveys. And this gets back to requirements elicitation. There's a lot of similar things. There's surveys, there's focus groups, there's ethnography and observation. With focus groups, you don't need many people. You can have like 5 people and get more out of a focus group than you're going to get out of a survey with 100 people sometimes. And it's because the advantage of a focus group, and this is where I would really encourage you when using a system, have the user do a talk aloud usability, which means that they're using the system and they're saying out loud what they want to do and why they're clicking where they are and what they intend to type. You can find when a user makes a mistake or when a user is not understanding something, you're going to find out what they were thinking instead from the focus group, and you can try to get to the root of what caused that confusion. There's also usability metrics, HRA, human reliability assessment, error rate. How often does user make a mistake? Higher this is, this implies that your user interface is confusing people. It's misleading them to take the wrong action. Or it's easy to make an incorrect action. Cognitive load. How much can the user keep their mind on during the task? Remember I talked before about how you can do like Control-S to save in some cases, and because that's so ingrained in my muscle memory, when I'm typing up like a notepad file I want to save, I just do that without thinking about it. I don't have to think, wait, how do I save again? Okay, Control-S. And over time using a system, you want that cognitive load to decrease, because then they can use the system for more advanced things because they're not thinking about it as much as how to use it. And then memorability, how much the user can remember the task. Perform the task and then come back and redo that task. Does it take you the same time, less, etc.? And you can actually time these things. Like you can time how long it takes the user to complete a task, how long it takes them to complete it a second time, how long it takes them to complete it a third time a week later. Error rate, just the number of mistakes they make, the number of incorrect actions. And then from there, so that's broadly usability, what I want to talk about. In class, we're going to do a little bit on visual metaphors, and we're going to talk a bit about that, so definitely come to class on Tuesday. There won't be a guided practice this week, so don't worry too much about that, but certainly this will be a fun little activity to talk about visual metaphors. So, with that, I will see you all in class on Tuesday. Have a great weekend, and take care. Bye.